Okay, my outstanding friends, this is going to be fun. We're going to go over electron flood theory, ether particle theory, and plasma. Very simple, very easy, but you should understand this stuff because you will be more advanced than a lot of the physicists. They're just starting to look into these things that have always been accepted as being correct, and they're not correct. The speed of light goes up and down, go up and anywhere. And even light slows down so slow that it becomes the cosmic radiation background. It's just the particles, it's called plasma. Eventually, it just is little particles that are just floating around out there. And they say light can't slow down. It can slow down to a literal stop. And then what happens is all the other light that is actually moving forward bangs into them as it's slowing down, and they pop on and off like little flickers. That's what the glow of the universe is. There's a lot to understand, and you can understand it better than most of the physicists because they refuse to look at anything that's not peer-reviewed. And they won't peer-review this because they say, oh, no, you have to be, the speed of light never changes. Space is a vacuum. We can see back to 650 billion, whatever it is. They're stuck in their dogma. They have been what I call mentalcided into believing things. Absolutely, this is true. There's no way I can start even look at that. And that's what happened to me at all of, well, anyway, that's another story. But I've been going on about this for, it's almost 10 years now. We could have had, I think, free energy by now. I really honestly do. And if you see what I'm going to show you, you make your determination. Okay, my friends, everybody loves a mystery. Well, get ready for this mystery because it plays into all my research. And you have to research every little piece to understand anything. You have to, first of all, understand what light and particles and atoms and everything is made up of, and then how, all of that stuff. And that's where we start, is with light, because light is where everything is made up from light. There's only two particles that exist in nature, and it's a muon and an electron neutrino. The two of them together make up everything that exists. So we are literally children of the light. Let's dig into this. Okay, let's just start with the fact that the universe is saturated with particles, which are light. Light goes from the sun to everywhere else. It comes from every star. There's a ton of little particles just floating around in the universe, and they call it the quantum foam. It's not empty. It's saturated with these particles that emit from the sun and from every luminous body. So let's just, and they claim it's 99.9% of the entire universe is made up of this plasma. What is plasma? This is from Goddard Space Center. And this is very well done. I'm impressed by what they did here to show what plasma is. And I've been showing this for years. It's basically, I called it atomic vapor. And that's all it is. It's atomic vapor. And the vapor condenses into particles, and the first condensed particle is light, and then the next condensed particle is protons and neutrons, and then it goes into molecules. But it's only condensed tiny little particles, tiny little magnetic particles. They're almost like little bar magnets, and I show all this very clear. And this goes back, this paper I wrote in 2018 was about this ether particle theory, which is what's causing all the interactions in the universe that they could never explain. And light slows down, so we really have no idea where we are as far as distances goes. Because light's not, first of all, it's not homogeneous. There's all kinds of fields and dust and particles and everything else, the cosmic radiation. You have to go through this. So if some places it's dense, some places it's thin. So the speed of light is not going to be, even if you could figure out, there's no way they can figure out where we are. It's impossible. This is the new atomic model. This was a paper in 2019, but I've had this model for 60 years, 50 years. Yeah, 50 years. And it calls everything dipoles. There's nothing but dipoles. And I'll show you what they are and how they are emitted from the sun. And then they have all kinds of interactions going on as the plasma in space is not just one, sometimes it's one little piece like this. Sometimes it's 10 of them or 20 of them or 100 of them or big globs coming off the sun. They will emit and then they go into space. Now, they will collide and smash and do all this, and eventually they'll break down into their tiny little components, and then they'll just sort of stop eventually, and they'll float around, calling the cosmic radiation background. So let's watch to see what Goddard has to say about plasma. And again, I was impressed. And here we go.
Out in space, particles play by a different set of rules than we are familiar with at home. The expanse beyond Earth is almost entirely filled with a mysterious state of matter. This matter is the least understood. It's rarely encountered on Earth, yet
Okay, I'm going to go back to when this video starts again. I kind of messed up. Here it goes.
out in space, particles play by a different set of rules than we are familiar with at home. The expanse beyond Earth is almost entirely filled with a mysterious state of matter. This matter is the least understood. It's rarely encountered on Earth, yet it triggers auroras and even impacts our exploration of space. This is plasma. After solid, liquid, and gas, plasma is the fourth state of matter. It is made of particles that have been ionized. This means the particles have been given so much energy that electrons separate from their atoms, making a subatomic soup. Unlike gas, plasma easily conducts electricity. This allows it to move along invisible pathways charted by the electromagnetic fields that fill space. While plasma is rare on Earth, it makes up 99.9% of the visible universe, including the Sun and other stars. It's also spread out across the universe and the space separating planets and stars. This space is not empty, it's filled with a weak soup of plasma. Those vast expanses of space are also filled with electromagnetic fields, such as those created by the Sun and Earth. In these places where plasma and electromagnetic fields play, plasma can undergo a unique explosive phenomenon called magnetic reconnection. Magnetic reconnection occurs where magnetic field lines are constantly shifting. When the lines become tangled, they explosively snap and realign. This transfers energy and sends nearby plasma particles flying through space. Magnetic reconnection triggers solar flares on the surface of the Sun, creates shock waves near supernovae, and violently twists plasma around black holes. Closer to home, magnetic reconnection between the Sun and Earth's magnetic fields is a critical way energy is transferred around our planet. For example, when magnetic reconnection occurs on the night side of Earth, it can push particles down toward the poles, triggering auroras. Near-Earth space is the easiest place to study magnetic reconnection, and NASA does this with its Magnetospheric Multi-Scale Mission, or MMS. MMS uses 4 identical spacecraft to measure magnetic fields and particles in 3D 100 times faster than previous missions. This has revealed new insights on the small-scale details of magnetic reconnection and the nature of plasma itself. Other NASA missions like Parker's Solar Probe, Themis...
All right, you won't have to hear any more of this. I am going to explain to you, we're going to go through this video again, I'm going to explain it bit by bit and show you precisely what we found. And we didn't have to go to this scale, planet scale. We can see this in the subatomic realm, which is nothing more, this is nothing more than a huge expansion of the subatomic realm. It's the exact same stuff, but we're going down into the subatomic realm. Let's take a look. Okay, let's just start with this. These are the 2 smallest particles anybody's ever been able to find. And this is Fermilab. And so these are the 2, and I claim exactly what they're saying, I agree. But we started with light, and we can see them in their perfectness, absolutely perfect. Now, in addition, they say this is the smallest particles that they ever can find, and this one has no mass, and that one has all the mass. I agree with that 100%. Now, this is the quantum foam, same place, Fermilab, and the quantum foam is these particles that are in space. It says empty space isn't empty. They know this for 10 years ago. Everybody's known this forever. There's no way for the light to get from the sun to us without coming through space. Anyway, and it says that all of these little tiny particles, they're subatomic particles winking in and out of existence. Yes, because they're getting smacked by other little particles that are slowing down as they're coming. That's why the redshift does not work. It's not correct. So we got a lot of thinking to do here. So now this is Fermilab, same people, and they're talking about matter and antimatter. It's not really that way. It's just, this one's the bowling ball and this one's the glowy part. They're the Dirac neutrinos. So these are also, again, the smallest particles that exist, elementary particles. And here's what we found. We found those particles that Don Lincoln at Fermilab talked about. The black one with the glowy edge, yes, there it is right there, with the glowy edge. And the red one, which is the glowy one, is here. Now, the glowy one can get big and small. The black one never changes. It's called a fixed particle. Fixed. Doesn't change. It's like a bowling ball. It just doesn't go in here. It's the same size no matter where it is. Now, when they are together like this, that's a photon. Because we use light. That's from a red laser light being accelerated and manifesting itself. All right? And this is what it looks like in colorized, so you can see the glowy parts. The different colors represent different energy levels. All right, so this is really getting kind of glowy in the center, and it'll get glow until it turns really bright white, and then it will absolutely just flip, because this one will be almost nothing, and that'll come to the front and start to absorb, because it's going this way. If you can see those little particles there in front of it, you see those little glowy ones right down there? All right, those particles there are what it has to bump into to get through the space. All right, light has to come through something, and here it is as it's coming through right here. All right, this is just light coming through space. All right, and these are all of the particles that are on gases and heat molecules and whatever they are, gases and whatever is in front of this. It could be moisture, it could be whatever it is. It has to push through it. And when it does, it slows the light down, and it excites both these. This gets very excited because it's really pushing, and these get excited because they got to get the hell out of the way. Now, we put it through a Venturi. All right, this is a Venturi. A Venturi means a restriction, just like a hose. You take your water hose, and if you don't have your nozzle on there, it just dribbles out. You put the nozzle on there, that's just a nozzle. Bzzz, it comes out of there like a rocket ship. Well, why? Because you restricted it. The same volume has to come through an extreme restriction, so it has to accelerate. There's no other option. And here it is right here. So here we're coming down very slowly, just like here, and it's just starting to accelerate. All right, and here's the acceleration starting to really ramp up. And here it's pulling itself right out of its own wave. And the particle is starting to illuminate itself. And here it's getting really illuminated, and here it just explodes. And when the explosion happens, what happens? It actually separates the black and the white particles. They come right apart. And the white turns into a shower of just whiteness. And the black can't get through because it's too big to get through the Venturi. And these are what they call the interference patterns. But that's because they think they do a double slit experiment. And they think they're flapping like this, causing these kind of waves. No, this is a spinning particle. It spins through there like this. Zip, zip, zip. Sometimes it comes over the top, it comes this way. Sometimes it goes over the bottom, goes that way. But primarily they come through the center. And they still just want to get away from each other. So they set up these patterns. And they start to reattach right here to the black. And before that, the black had separated. Now, when they do come out of here, and they're looking straight into here, you would see this. Those are the Higgs fields, where the two particles come back together. The white, which is nothing but white here, comes back and hits some kind of, the black particles have to be just laying around out there because they recombine. I'll show you that in more detail, uno momento. And these are the particles. And again, a more detail, uno momento. And this is blue coming through extremely fast, spinning, and then slowing down. See how fast it is here? Real tight, and then it slows down. So light speeds up, light slows down. It's the same particle. The green, the blue, the red, they're all the same particle. And we can see those particles quite well. Here they are right here. As they start to accelerate, and then they get the glow on. I get the dust off, they get the glow on. And here they come. Zip. These are the neutrino phases, where they're not really fully photonized. And here they smack into the Venturi. And the only reason we're seeing these way out here is because they're building up energy. They have to be really energetic before you see them into this phase. Usually you'd only see them, I think, when they're bouncing off of something. But here they're just building energy because of the Venturi. So now here, this starts to get very, very interesting. Hold on one second. All right, here's what you have to understand. For some reason, and I think I sort of understand it, everything's being dragged through the Milky Way, on the arm of the Milky Way in a circular pattern like this. And our sun is one of these particles, and we follow the sun because it's attractive to all of these planets that follow it. And we spin around it because everything spins, and it has a right-hand rule. Now, the sun additionally spins, and it has to plow through everything in front of it. And I can show this quite well, what its interaction is as far as energetically. Now, the planets, you got Mercury, you got Venus, and you got Earth. And I'm going to show you something that is very, very interesting. Hold on. All right, here's the sun. It's behind the moon. This is a total eclipse of the sun. Now, you see that red spot, that red spot, that red spot, and these big magnetic flux fields? That's happening on the surface of the sun. You just consider this to be the sun, but you can't see it because it's blocking it, so you're not blinded by the light. These are the poles. And the sun is spinning this way. And I know that for a fact because the interaction is here, here, and here. So this body is spinning this way. It means this is plowing harder into the atmosphere that's coming at it, because it's coming through, all the atmosphere that's in front of it is nothing but plasma, and it has to push its way through that plasma. So it's pushing, and it's very, very reactive here, here, and here. You see the red, 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 and a big here. This is trailing. So I know the sun is going that way and spinning in this direction. I would say it's going that way. I know it's spinning in this direction because it's making these, it has to be going this way. Otherwise they'd be equal on both sides. I would think. They'd be equal on both sides if it wasn't traveling that way. That's my guess at this moment. But here's the interaction spots, big bubbles of energy. And here it's just trailing off. You can see it's almost, you see it coming, and they show these exact same patterns coming back and making a snap at the end when they reconnect. These are the reconnection snaps. All right, so let's dig a little deeper, but don't forget this image. It's going forward this way and spinning this way. And we're following it, and all the planets along with us. You see that? This is our neighborhood. This is right down the street from us. That's the moon, and this is all what's going on. And this is looking out. Every one of these is a dipole, and they all have magnetic fields surrounding them, if you see. And there's one big, hell of a big one out here. Now, Jupiter is around here. I'm sorry, Venus is around here somewhere, creating a lot of magnetic anomalies. Now, this other stuff here, I mean, I don't have good explanations for all this little crazy stuff like this. It looks like it's a pyramid. This looks like Atlantis, and these look like spaceships going back and forth. And it could be. It could be. I'm telling you. Who knows? Now this is blue shifted. So here's what's going on with the moon. The moon is going that direction. it's crushing the light, making it shift into the blue and shift into the red here. So light will shift its frequency if it's being crushed or pulled, yes. But the galaxies aren't expanding, and the universe isn't expanding. Its light is just slowing down. And the universe might be expanding, I don't know, I have no idea. But they don't either, so it doesn't make any difference. They don't know, I don't know. But I can tell you what, for one thing, there's no question whatsoever. Light coming through this is going to slow down. And this is a saturated universe, absolutely saturated. So the things that they think are 650 million light years away could be right down the road. I mean, literally just a couple of blocks away. I'm telling you, they have absolutely no idea. There is so much stuff in space. This light is coming through. They look out and they say, oh, this is a bazillion miles away, because they're looking through a ton of debris and everything has slowed down to almost a crawl. So they say, oh, that's really going. And now it's going so fast that you can't even imagine the theories, but they're all based on the fact that light can't slow down and speed up, and it's just not right. I show it's not right. It's absolutely 100% not right. Now here's another thing that they should start to consider. I can't believe they don't understand this. You saw what happened to the sun. It's scrubbing through like this and going that way, and there's extreme hot spots. Now, we're somewhat in the same situation as the sun. All right, the sun out here is 10,000 degrees on the surface. Way out here where it scrubs through all these particles in space, which you just saw it scrubbing like hell, it's millions of degrees, millions, 10,000 on the surface. They have no explanation for this. If space is a vacuum, it should just float through there, no problem. No, it's not a vacuum. And I showed you, no question whatsoever. We have the same situation here. On Earth, let's say 100 and whatever degrees, normal temperature on the Earth. You get out here, way out where the scrub zone is, and you're into thousands of degrees. Again, no explanation for that whatsoever. And that is what the global warming is happening, because we're expanding our gaseous envelope by burning things. Whenever you burn something, instead of being a little tiny particle like this, it becomes a gigantic, huge thing. And our envelope is blowing up like a balloon. The higher it gets, the more scrub you get out there, the more turmoil, the more condensation, rain, and all kinds of things will happen in certain areas where the air rises up quick and smashes into, you get all kinds of electrical discharges, and you could have all kinds of, well, we have all kinds of problems. Weather patterns shift, and it's because of this expanding envelope. We need to get free energy. We need to somehow use this kind of energy right here, this white power. Fire up the batteries. That is just nothing but power. And we can separate it using the Venturi. I've shown that very, very well, and I can show it in extreme detail. And the white is all we want. And I've always been showing this for years now. If we can shoot that white through here and collect it there, we're golden. Just for the laser, a Venturi, and collecting it. We're not using protons, so we're not using the big things that damage things. These will damage you. These will kill you. If you get hit with these, they'll kill you. This will not kill you. This is light. You see this all the time. This is light. You don't want to look into here. No, absolutely not. But a zillionth of an inch out it's all gone again, and it's back to being its normal particle. So you can't get hurt with this. It can't get out of control. And you can just run it all day long, and you're going to get all that white power coming out of there. And that's all you want, is the white side. The black side you want to keep from going into your batteries. The batteries don't gain weight at all, because the white side has no weight to it. Exactly what they said at Fermilab. They're right. The white side has no weight whatsoever. The black side has all the weight as a fixed particle. It can't get through the Venturi. The white can, because it squishes down, and it has all the energy. Once we get it on this side, we should be able to use it. All right, so let's talk about this plasma now. I say that the entire universe is completely saturated with it. And this is from, Dylan Carpenter took these pictures with a cell phone. I don't know if he has a special app or whatnot, but you can see they're all dipoles. And that's the moon, and you can see the moon is moving in this direction, crushing the light, turning it blue, and so forth. Now, that is this one here, I believe, is Jupiter. No, I'm sorry, Venus. And the reason I say that is it has two magnetic fields, and they look like they're reversed. I mean, they're both in the same plane, because what's happening is Jupiter, I mean, boy, I can't keep doing that. Venus is going around like all the other planets, but instead of spinning in the same direction, it's spinning backwards. So all I can take from it is that because it's going around the sun, the same as all the other planets, it's creating a certain magnetic field. But its reverse spin is creating another magnetic field superimposed on the first one. You see it? Let me home down in that. You can see it a little better. All right, I hope you can see that. So it looks a little blurry to me, but it's obviously a very, very, very serious dipole, and that's what Venus is. And it's overlapping our moon with its field. It's just an enormous, huge field. And of course, then there's all these other dipoles. Everything that's spinning in space is a dipole. And this is a dipole of rolling this direction, scrubbing all of the particles in space, and spinning backwards, scrubbing against whatever else. And I think it's creating one weaker field, but it's huge, and one really tight field, which is hard and tight and really, really reactive. You see how reactive that thing is there? It stops. This one here is just sort of fluffy and way out there. Very strange universe, my friends. All right, this one here blew my mind. This is Earth. Now they got some space camera out there that's watching things. This was an asteroid coming through our region of the solar system. This is Venus. Now look at this field, and the same thing with Earth. It's very strange. This one is the strangest, because the sun, Venus is between the Earth and the sun. So I believe the sun is over here banging against Venus. Instead of being bright here, which it should be, because it's banging, this is spinning backwards. It's bright on the other side, which is not the side that's being impacted. See, like we're Earth, we're being impacted in our atmosphere out here by the sun, and it's glowing because it's being impacted. And then as the particles come and wrap around the Earth, they snap together back here, and they make a snap. And look at this, it's blank. This has got me perplexed, I got to be honest with you. Why? It's somehow obstructing the glow of these things are still out there, because these are all dipoles in space. They must be stars way off in the distance or whatever. But there's something out there. These are some kind of particle things. And what happened here, I don't know. But I can tell you what, this is the wrap around, and they talk about this all the time, and it'll show it. It hits the magnetic field, they wrap around, and they come around, they go snap. And whatever that snap left over is there. And this is backwards. That is a backwards field. It should be the black on this side, the white in the front. Same here. This has got the black in the front and the white on the other side. It's got an inside core of a black and white. That's just crazy. One side should be black, one side should be white, one side should be black. That's it. That's what it's supposed to be. And this side is interacting, so it's all puffed up. That one never changes. The black side is just always the black side. And look at this. It's got a black inside white and a black inside and a white outside. That's got to be Venus. And this thing here looked like it shot a pulse at us, and another pulse, a wave came back out at it. Now, whether it just had an electric discharge that was looking for a place to discharge and just normal, or whether it's tried to shoot at us, I don't know. But when I saw the video of it, I don't have that, I can't find it. But there is a video showing this thing discharged something this way, and out came a wave like this from Earth, which could just be the magnetic attraction of a discharge to another attractive, or, you know, in other words, just a normal magnetic interaction. Think about it that way. Or it could have been they tried to shoot at us. I don't know. I have no idea. But it was kind of perplexing. And it goes back to 2021. It was on 12/11/2021 at 16:08:51. And I can't remember the name of the asteroid, but they had a little bit of discussion about it. They were a little concerned that it was going to disrupt something, or I don't know, I can't remember. But that was it, and this is what I saw. And it again, I have to try to justify and understand everything that I see. And I do understand Venus could have a double crazy thing going on there, because it spins one way and spins backwards the other way. And it's the only one that does. All the rest of them have normal fields. And anyway, what we're going to do is go back to that Goddard video, and I will explain and probably jump back and forth to this to actually show the interactions that they're going to be discussing. Because this is plasma in space, and we've seen it. There's no question we've seen it. And let's just go over a couple last things. Some of these things I don't think I showed you. But I did show you, I believe, the light building its intensity and then exploding at the Venturi. And here's what it looks like right up close. All right, when it hits the Venturi, the blacks can't get through. They stay over here. And the white showers through, and then the black reattaches. And that is called muon neutrinos. The black one is the muon, and electron neutrinos stuck together normally, and then they turn into electron showers. It's exactly what you see here. These are electron showers. These are the muons, the black ones, and then they come over here. It's called a sterile muon when it's not part of the neutrino. And this is the shower when it's not part of the package. And here's the package that it should be, is right here, these two. And the black separates from the white, and the white showers through. This is the blue coming in real hot, and you can hardly see it's two particles, but as it slows down, and you'll see the two particles start to show. But you can see it's fast here, spinning, and it does spin, and it's slowing down the spinning rate. And light sort of spins and, you know, moves not in a straight line. They're right. I think they talk about that in that video. I don't know. I've just watched so many of them. But what else didn't I? Well, here's the light spinning. And this is exactly what I said. Light goes this way, and then sometimes it comes over this way. But most of it gets, because there's a whole batch of them coming through. It's not just one. So they're all over the place, and some come over this way, some come over that way, some come over this way. But once they come through the Venturi, they stay apart from each other because their energy fields will not allow them to get close. So they set up these patterns. They call them interference. Again, single slit, no double slit. What else didn't I show you? Oh, I don't think I showed you the green one. Here's the green, the same deal. It comes through real hot. And then you see the particle. There it is. The green is identical to the red. There's no difference. And the blue is the same. The blue you really can't see because it's just too fast. And the green and the red, you can see how the red here is not powerful. And it just gives up about out here. And the green just pushes the red out of the way and reconcusses way out here. So the green is much more powerful than the red. Now, having said the green, the blue, and the red, that's because those are the lasers. Light will come in every single different color of the rainbow. That's just what it is. So these three happen to be what is emitted from the crystals, that the red, blue, and the green, that make the lasers. But other light coming out of the sun and so forth can come out all over the place. Now, here's the key. Here's the key. Here's what Higgs, these are the Higgs fields and all of the particles that they see at CERN. And they dig through these particles, literally hundreds of people for years and years and years, to find these smallest particles. And they did. They found the same particles we found, but we used light. We didn't have to start with all this. And we could see them develop, and we know how they developed, and we know basically everything about them at this point. They see the same sort of fields because they all make the same fields. And these are our Higgs fields. This is when our light comes back to making the Higgs fields. There's just a bazillions of them. And they're looking for like 130 Higgs fields on every big blast they do over there. We can have that less than a second. We have thousands and hundreds of thousands. So this is not a big problem because we started with light. So they started with this big mass of stuff that just flew everywhere. See, it's just everything. It's just a big mess. Now, we started with the light so we could see the light develop coming through here and then actually create fission and fusion. And this is fission and fusion. There's no other way to look at it. Where did it go? Right here. That's fission. The black came away from the white, and here came back together. That's fusion. In the middle is raw white energy. And I think that could be used to do some work. This is some serious stuff. This is no joke. Now let's go back to Goddard and see what they have to say, and I will make my comments about their comments. Okay, here we go. This is NASA Goddard Space Center talking about the plasma. What is plasma? And I showed you what it is that white juice that I showed you. And it's all kinds of particles.
Out in space, particles play by a different set of rules than we are familiar with at home. The expanse beyond Earth is almost entirely filled with a mysterious state of matter. This matter is the least understood.
This is nothing more than sunlight and particles in space. Now, they're going to be banging into all the other particles that are out here, which is called the cosmic radiation background, the microwave radiation background, which is just, they're just laying around particles. That's why you're seeing all these blinking. And that's exactly what they said at Fermilab. Quantum foam, subatomic particles winking in and out of existence just all over the place, like bubbling on a root beer. And that's what's happening here. Because these particles being emitted, they have to get slowed down, and they will. And so the redshift is just slowing particles. And every time they bang into one, they get slower. They bang into another, they get slower. They bang, and sooner or later, and that's it. And then they become the ones that these guys bang into. So here it goes.
It's rarely encountered on Earth.
You see, you saw it all around the Earth now.
Yet it triggers auroras and even impacts our exploration of space. This is plasma. After solid.
This is exactly what I show you. Now, in space, it's free to float around. We had to shoot it through the Venturi to turn it into the plasma. But out there, once it's shot off of the sun, it's sort of free to float around. It may start to congeal surrounding a black mass. And why do I say it will congeal surrounding a black mass? Because of this. Don't forget, this is in space. These are these charged particles, and that's what they are. They come off the sun as charged particles. Everywhere in space, charged particles. You see this? The Russians did this back in, I think it was 2014, 2015, and I actually communicated with them. It didn't really work out because they, anyway. Because I said, I think I understand what's going on because of our light research. And these are the white particles surrounding a black hole in a vacuum chamber in space. And they flipped out. They couldn't believe it on Earth when they saw this. They all freaked out. They still don't know what happened because they can't explain it. Well, what it is these are the white charged particles. There's black particles everywhere. It seems like they're just everywhere waiting to be congealed by the white ones surrounding it. So there's black holes probably just about everywhere in space. And they're tiny, tiny ones. And they'll probably just get bigger and bigger and bigger. Because the more and more white particles that attract to them, the bigger it will grow. This is gravity. The black particles are gravity. And that's why Earth, it must be saturated with black particles. Because all the electricity, the white particles, you get them next to the Earth, and they go right to Earth. Static electricity collects on you, right to Earth. Lightning, right to ground. Light comes down and hits the Earth. It warms up the Earth. So that's exactly the same case as this. And they freaked out. I have the video about this. And they also found a double helix. It formed a double helix in here, just like DNA. It freaked everybody out, and then they just all dropped it because once these things freak people out, and they start to think, everybody starts laughing at them. They say, "Oh, they can't mean anything. I just forget about it." And they do. They forget about it. That's a black hole. All right, this is just too cool not to watch. This is the Russians in space, and they're speaking Russian, so it's in English subtitles, and I'll try to explain what they're doing. What they did was they took a vacuum chamber, which has no particles in it, no gases, no nothing, supposedly. And then they injected dust particles, charged dust particles, and then to see what would happen. Now, what they expected to happen was all the charged ones would push each other apart, and they'd actually get almost like a lattice work in there, so that it would be, everybody would be pushing each other apart, and it'd all stay apart. And that didn't happen. So here we go. All right, so here they are, the Russians in space. This is a couple little clips here. And here's what's happening. The vortices in the plasma created like a galaxy look to it. You see it? And this is the plasma that was inside this vacuum chamber. And they were doing all kinds of experiments with it. But it ended up showing that oh yeah, they're going to show the DNA shape. Here, look at this. It showed up in a DNA shape. Look. That's freaky. All right, but the big one here to take away is the one here, down here, right here. This is the one. He said they were looking for this clean lattice I was talking about. And so he says instead they were looking for a clean lattice, and this is how it all settled out, and boom, that's what guys on Earth freaked out. One guy locked himself in his office. Science at Planetary Institute told us that he freaked out upon receiving the data, locked himself in his office for several weeks. Nobody could figure out what they saw. And they still don't understand it, but it is the black hole. The dark particles can separate from the white ones. I never thought that was possible. And I believe there's a lot of excess dark ones, it appears to me. Because I believe the white ones are always attached normally to dark ones. Well, but that's, in space, like they said, they don't play by the same rules. They can separate and just sort of go on their way, and sooner or later they'll clip onto something. It appears, I don't know. That's the plasma, I can tell you that right now. Okay, so let's get back to this now. Don't forget, there's 3 normal conditions of matter. There's solid, just solid things. There's liquid, and then there's gases. Now, the 4th state of matter is plasma, and that's the stuff I was showing you, the white and all that stuff. And it's all the particles that are in space. It's all the emissions from the sun. It's light. All right, here goes.
Solid, liquid, and gas, plasma is the 4th state of matter. It is made of particles that have been ionized. This means the particles have been given so much energy that electrons separate from their atoms.
Exactly. The electrons separate from, they're saying from the atoms. I'm saying the electrons can actually separate from the muon neutrinos. These are electron neutrinos, muon neutrinos. They can separate. And that's really maybe the 5th state of matter. I don't know. Here it goes.
Making a subatomic soup.
Exactly.
Unlike gas, plasma easily conducts electricity.
Actually, plasma in the case which I was showing you is electricity. The white stuff, that is electricity.
This allows it to move along invisible pathways charted by the electromagnetic fields that...
Now remember I showed you before there was that trailing thing where, and it snapped. Well, I'll have to go back and show you, but let's watch this and I'll show you. She's going to show how they snap back together.
While plasma is rare on Earth, it makes up 99.9% of the visible universe, including the sun and other stars.
Okay, that I don't agree with. The sun and other stars are masses of literally dark matter. Has got to be somewhere in there, a lot of it, and then there's a lot of electrons that are seeking that dark matter, just like the Russian thing, and it shows that they're trying to get on there, and then once they do, they have to scrub through everything that's in front of it, because it's just a ball of little white particles, and that's what they have here. And as it's scrubbing through, I showed you these big areas where you get a lot of magnetism and you get a lot of energetic reaction, those red spots. Let me just show you those two things and then we'll go from here. Okay, the first thing she was showing how the particles come back and they snap back together. See, that's what a snap is, I believe. Whatever it is, that's all I can tell you. There's some kind of strange thing, and that there is a snap that happens. I have to agree with that. It certainly makes sense. Let me put it that way. Now, then again, don't forget, these are these extremely energetic reaction zones, and they spit out particles. Now, they could spit out little particles, big particles, chunks, gigantic chunks, whatever they want. Now, the biggest and heaviest stuff is going to come and fall back, and that's what those magnetic lines are. They come out, and the big chunks will come right back. Not right back, but they'll come back. And the weaker or smaller particles, not weaker, there's going to be just very, very energetic, but they're going to be much smaller. They're going to be able to escape. You see that? These are globs of things, like big blobs of masses of things, whatever they are, and they jump out and then they come back because they're globs. the light particles just keep going, as I showed you in that solar eclipse. All right, so let's go back to here again. The electrons separated from the atoms, making a subatomic soup. Well, not only can you separate from the atoms, you can separate them from the muons and make a real particle soup. Okay, so let's go back to listen to what she has to say. Hold on one second, let me set this up. Okay, here we go.
Subatomic soup. Unlike gas, plasma easily conducts electricity.
Again, the plasma is only, the white part is the electricity.
This allows it to move along invisible pathways
and there's that wave, and then they snap. After moving through, they make a snap.
By the electromagnetic fields that fill space. While plasma is rare on Earth, it makes up 99.9% of the visible universe, including the sun and...
Again, the sun is not made of plasma. The sun is made of something that is dark matter, just like the Earth and everything. As far as I'm concerned, my research tends to indicate that everything is pulled around a dark center, because of the dark matter that doesn't mind being on top of each other. It'll just push right to the center, as I showed you from those Russian experiments. And then the white matter collects. The more white matter, the bigger it gets, the heavier it gets, because the dark matter is pushed to the center. More and more dark matter keeps collecting into the center because it comes along with the white matter. Or maybe the dark matter just migrates by itself into these black holes, but the dark will just migrate right to the center, and then surrounding it is this stuff. That's the glowy stuff, and then that has to scrub through the rest of the universe. Now again, as these globs come out of here, they can be huge big blobs, they can be little ones. If they get far enough away, they're just going to keep going. A lot of them just come right back.
Other stars. It's also spread out across the universe.
Now, the other thing is, how could they possibly think that nothing is going to slow down coming through this soup? It just boggles my mind.
And the space separating planets and stars. This space is not empty. It's filled with a weak soup of plasma. Those vast expanses of space are also filled with electromagnetic fields.
I showed you those, with all those huge fields surrounding every dipole in space, and anything that spins is a dipole.
Such as those created by the sun and Earth. In these places where plasma and electromagnetic fields play, plasma can undergo a unique explosive phenomenon called magnetic reconnection.
All right, here's where they're going to show that where I showed the Earth was here, and in front it was glowy, and behind it came wrapping around and snapped, and then there was just some blank spot. That still got me perplexed.
Magnetic reconnection occurs where magnetic field lines are constantly shifting. When the lines become tangled, they explosively snap and realign. This transfers energy and sends nearby plasma particles flying through
Whoa, that was interesting. Remember how I just said I couldn't understand how we had that blank spot? So the Earth is going this way, crushing the fields. They're wrapping around, coming snap, and then they're opening up this blue field. I mean, that's just a representation, but
they explosively snap and realign. This transfers energy and sends nearby plasma particles flying through space.